Augmented Analytics. Lecture 3. Today we will learn about exploratory data analysis. Introduction to Exploratory Data Analysis EDA techniques, descriptive statistics, histograms, box plots, etc. Correlation and regression analysis. Exploratory data analysis. Exploratory data analysis is an approach to analyzing data that focuses on understanding the data's main characteristics, patterns, and relationships by using statistical and visualization techniques. EDA aims to uncover important insights and trends in the data that can inform subsequent analysis or modeling. It is an important first step in data analysis and is used to gain an initial understanding of the data, identify potential issues or outliers, and generate hypotheses for further investigation. EDA typically involves summarizing the data using descriptive statistics such as mean, median, mode, standard deviation, and range. Visualization techniques such as scatter plots, histograms, and box plots are also commonly used to help identify patterns and trends in the data. The goals of EDA are to understand the data and its main characteristics, identify potential outliers or anomalies in the data, identify any missing data or other data quality issues, generate hypotheses for further investigation, identify potential relationships or correlations between variables, determine if the data is suitable for the intended analysis or modeling task. EDA techniques. Descriptive statistics, histograms, box plots, etc. Exploratory data analysis. EDA uses various statistical and visualization techniques to understand and explore data. Here are some commonly used EDA techniques. 1. Descriptive statistics. Descriptive statistics summarize and describe the main characteristics of the data, including measures of central tendency, mean, median, mode, and measures of variability, standard deviation, range. 2. Histograms. Histograms are graphical representations of the distribution of a continuous variable. They show the frequency of values falling within each interval bin of the variable. 3. Box plots. Box plots summarize the distribution of a continuous variable by displaying the median, quartiles, and outliers. They can be used to compare the distributions of different groups or variables. 4. Scatter plots. Scatter plots show the relationship between two continuous variables. They can be used to identify patterns, trends, or outliers in the data. 5. Heat maps. Heat maps show the density of data points within a matrix, using color to represent the frequency or intensity of the data. 6. Bar plots. Bar plots are used to compare categorical variables. They show the frequency or proportion of observations falling within each category. 7. Correlation matrix. A correlation matrix shows the pairwise correlations between multiple variables. It can help to identify potential relationships or dependencies between variables. 8. Outlier analysis. Outlier analysis identifies potential outliers in the data, which may indicate data quality issues or other anomalies. These are just a few examples of the EDA techniques that can be used to explore and understand data. The choice of technique will depend on the type of data and the research questions being addressed. EDA is an iterative process, and multiple techniques are often used in combination to gain a comprehensive understanding of the data. Correlation and regression analysis. Correlation and regression analysis are statistical techniques used in data analysis to study the relationship between two or more variables. Correlation analysis is used to determine the strength and direction of the relationship between two continuous variables. It produces a correlation coefficient, which ranges from -1 to 1. A coefficient of 1 indicates a perfect positive correlation, meaning that as one variable increases, the other variable decreases. A coefficient of 0 indicates no correlation, meaning that the variables are not related. Regression analysis, on the other hand, is used to model the relationship between a dependent variable and one or more independent variables. The goal of regression analysis is to identify the best fitting line or curve that describes the relationship between the variables. There are two main types of regression analysis: simple linear regression and multiple linear regressions. Simple linear regression involves modeling the relationship between a dependent variable and a single independent variable. Multiple linear regressions involve modeling the relationship between a dependent variable and multiple independent variables. Both correlation and regression analysis can be used to identify potential relationships between variables and to make predictions or estimates based on those relationships. However, correlation analysis only identifies the presence and strength of a relationship, while regression analysis provides a more detailed model of that relationship. It is important to note that correlation does not imply causation, and that additional analysis or experimentation may be needed to establish causal relationships between variables. Thanks for watching. Wait for more informative video.